morning, everyone. So thank you for joining this session in this number. Really appreciate it. So first of all, it's really great to be back after 2 years of speaking now on Tech Days. It feels fantastic, and even more fantastic to see you in this number. So this event continues to be like the point for innovation, knowledge sharing, and basically for Business Central development group to gather and share some knowledge. So I'm pretty excited to share some fresh insights with all of you today. Whether you are basically experienced developer or new developer just starting to optimize your code, you will get some tips which you can use. So, and if you are experienced developer, you will be familiar with some patterns, and if you come out with some few tips, that's still success for you. So we all know that L coding isn't just coding and that's it. So it is also about performance, maintainability, scalability, and everything. So in this session, we will go through those principles. But first of all, before we dig deeper into the details, let me introduce myself. So my name is Stefan Šošić, for those who don't know me. So I'm Microsoft MVP now, focusing on Business Central development on first place. So through my LinkedIn blog, GitHub blog, I am focusing on technical stuff, Business Central development topics. There are some also functional, but more into development ones. So let's start with the details and first examples and start optimizing the code itself. So before we start, let's introduce how we will perform the tests with the results. Results are pre-run in this case, not to wait for some long queries to execute. So we will be using the toolkit itself. So I created little toolkit here in Visual Studio Code, which we will be executing region by region, and then checking it out in Business Central by each example, checking some charts and checking how it performed. So that's first thing. So yeah, next thing, how the queries were analyzed. So with SQL Query Analyzer, and they were cached with SQL Server Profiler. So we will be checking the demos, checking the times, and then moving to the queries, how they look on the SQL level, and then we will see some conclusions based on that. All the tests have been run onto the separate sessions, so, and also without user caching. So after this slide, we will see how is that part done. But the results which we'll see in this session will apply also for on-prem or on SaaS, and the tests are verified on newer versions. So I did the tests on BC 25 and 26. Why I mention this? Because for some parts, there is Business Central platform optimization, which automatically does some optimization of your SQL queries in the background without you knowing it. And I will see that in a bit on the first example. But on the previous version, I didn't test it, so it's possible that some of the feature you cannot use on earlier versions. So I already said that we will be using raw results, not the cached results. And we are doing that with, before each call, we are calling database select latest version. And what will that do? It will clear all non-locked records from the client cache and also the current session cache from the user. So each time we'll be calling the database, we'll be getting the pure performance between the Business Central and the SQL. So you shouldn't do that on your production environment, of course, or if you don't know what you are doing. In this case, we just need it for performance, so we'll be using that for this demo. So what is NST caching? So benefit of NST caching is when you already run it, you fill the cache, and next call won't execute any SQL queries in the background, so you will have the benefit automatically pulling the data in milliseconds from the cached results. So for that example, let's just quickly go through that one. I created just a simple loop going through the customers, findSet, and that's it. And that will be with NST cache. So we will not be calling database select latest version for that example, and exactly same version where we will be calling database select latest version. We will see now the results. So for these results, we have been creating 1 million customers to fill one large table, and also vendor table, which is dynamic. For some examples, we had to do it with a smaller amount of vendors, some with full, so we will see that on further examples. So two tests have been run. Duration is, of course, better with NST cache because it is automatically pulling it from what previously has been pulled from SQL itself. But what it matters and is SQL statements executed. So only once the SQL statement is executed, meaning that once we pulled the data and that's it, then we read it from the memory buffer itself. But without NST cache, which will test further examples, we'll be executing all the queries again and again. So we will not benefit in this demo from caching. So as you can see, also SQL reads. So NST cache has just one on the first run. So if we check NST cache, you will see that on the first run it needed some more milliseconds to load, but then it pulled just the cache from its memory, and that's it. Okay, since we explained that one, let's move to the first example. So if you have been following me for some time, I've written some blogs regarding whether you should not or you should write isEmpty before findSet or vice versa. So, and actually this is the first example where the BC platform optimization happens. So when you repeatedly execute findSet, SQL will be creating stored procedure for you, and after a while, it will wrap it around if exists, and then if you execute isEmpty before, it will be redundant in this case. So let's first check the demo, and then we will move to the queries itself. So the code is pretty simple. So we are again looping through the customers here, and we are saying, okay, set range, country region code, and if not customer is empty, then findSet. That's it. In the second example, we'll be using without isEmpty. So we will be looping through the code of customer table and then just doing findSet. If findSet, then again some code. So without this part, if not isEmpty. How that will perform? So on the 1 million records here, there is significant difference just with some calls. So in these few calls, there is a difference between 2 seconds. So, but what is more important and why it happens is the number of SQL statements, because because, like mentioned, for isEmpty you will need additional query to be executed before findSet, and that will be doubling the queries. So findSet without isEmpty will take 3,000 queries in this case, and if we do it, same example with isEmpty, we will double the amount of queries. So it can cause also the SQL overload, and that will impact the performance. And this is just one session, one example. So if you have multiple users and so on, so it will be affected more. Okay, so this is on the full table. What are the results on the 50 record table? So we are using in the background vendor table with 50 records. So we still benefit even though it's a smaller table. And now you will say, okay, when it is always empty, so not 99%, but 100% it is empty. findSet without isEmpty will be actually a bit slower, but when you have like the table with 100% isEmpty, so those are rare occasions, and I think you can benefit more if you use just findSet without isEmpty, because in most scenarios you will have at least few times table filled. And in this case, we'll be executing the same number of statements, because on the one hand we will be executing isEmpty statement, on the other hand just the findSet. Okay, so let's analyze now the queries. So here we are having here we are having the first query, which is for isEmpty, and that one is checking isEmpty, and then followed by findSet procedure, which gets the data set into the buffer itself. So let's take a look now when we repeat just the findSet multiple times. On the first run, you will see the SQL Server creating a stored procedure for your filter. So, and it looks like this. And after a certain amount of running, you will get if exists in front of the stored procedure. It is not in the same stored procedure, so the new stored procedure is created and wrapped around with if exists. And that's basically the Business Central platform optimization, which I was talking about earlier. So how does the full flow look like? So on the first run, there is first query, just simple findSet, that's it. On the second run, we are executing that stored procedure. On the third run, again, the same. But on the fourth occasion, like I said, now Business Central platform detects that what you are doing, and it optimizes your query automatically. So automatically, new query is crafted with if exists in front. And after that, each call which you are doing, it will be executed from that stored procedure. So this stored procedure is 60, so it's not executing anymore the old stored procedures. So on graphically just displayed, so if it is empty, we are checking with the database, making the calls with the database, then we move further, and if we are doing the findSet, at some point it gets wrapped with if exists, which additionally sends queries to the SQL database and causes overload and performance downsides. Okay, so let's move to the next examples. So setLoadFields, I guess most of you use it, but on most cases maybe you forget also some places to put it on. It won't magically solve all your problems, but it is really valuable pattern which can lead to performance improvements. And what it does also, it limits the number of loaded fields. So based on the queries, which we will take a look now, we will see why the performance is just performing better. In most cases, you just heard that you should use like setLoadFields, it will load just some fields, and that's it. But we will take a look on the SQL level and see exactly what is happening on the background. Okay, for this example, no setLoadFields, so we will be looping through the customer, checking the place of export, for example, and if the condition is true, then we will add it, for example, to the list, and that's it. In second case, we will be doing setLoadFields, which will load just the fields which we need for our logic, what should happen, and primary keys will be automatically loaded, so the customer I know you can still use. And let's see the results here. So, like I said, the customer table is a bigger table with 1 million records. So if you are looping through with difference with this just optimization, with setLoadFields and without, you will get significant difference. So in this case, more than 25 seconds here. Number of SQL statements is the same. So what is the difference now when we have the same number? In previous example, we had more SQL statements, so less performance. But in this case, same number of SQL statements. So the main difference would be how SQL statement is performed and the weight of it. So let's analyze that one. So with setLoadFields, you are loading all the fields from the table. So you get all the fields, and if there are some table extensions, you will get also those fields from table extensions. So if you are optimizing your extension fully, it can also happen that some other extensions affect your performance while loading those fields from other extensions, not only yours. But when you are doing with setLoadFields, you can specify which fields are you loading and prevent like additional joins with additional table extensions which connect to that table and so on and so on. So it's much more optimized and lightweight query, and it just needs to read less data, and then of course takes less time for it. Okay, so let's move to the next example. So with find minus or findSet, maybe during the upgrades, or you find some old code, you find into some occurrences where you have find minus and then looping through. And if you have more than 50 records, it can cause worse performance in this case. Why? Because find minus will just load 50 records, and that's it. And when next statement is executed, it needs additional call to the database to refill the buffer. So let's actually use the next slide to better understand. So with find minus, we pull from the SQL 50 records. And if we loop through and there is more than 50 records, with the next statement, it needs to new query to be crafted and sent to SQL in order to pull the full data set. So that's actually one additional query which will be taken and which you need to take in consideration based on your table size, and it can impact the performance. So for this example, find minus. So, yep, the same here. I did some changes the last moment before. So the find negative here, we are just setting the filters, then doing find minus, and repeating it true. And as the comment says here, when it reaches more than 50 records, and next is executed, you'll be pulling again from the database. So, and with findSet. So you are loading the full data set in front, and you don't need additional queries. So let's see that chart of the performance, so to say. So with phi minus, there is, of course, worse performance. And with just findSet, since you are loading the full data set and having it into internal buffer, you are performing it better. When you end up with 50 records and then needing it more, there has also memory relocation to happen to extend the buffer and relocate more memory for it. And the difference here is more into the SQL statements. So you see the double number of amount. So this example was run into the loop. But each time when you have more than 50 records, you get one more query. And let's see from the query side how is that looking. Okay, so when you have phi minus, you load first 50 records. So query is just simple one. We will be not combining too much of the patterns together. We'll be just using, of course, it can be optimized like to use setLoadFields to get smaller query and so on, but we'll be focusing just on this example isolated. So 50 records, then you loop through. It doesn't send any query because it is internal buffer. And when you hit 50 records, and then there is a need to pull one additional record from your dataset, it actually creates another stored procedure. That stored procedure is same in some ways. The load and the fields which need to be loaded are the same, but it starts from the last record from the previous query. So the first 50 record will be thrown away, and then starting from that point, loaded. So if you didn't saw basically the difference, here is just the compare between the queries. So it's mostly the same, but it's doing different things. The first one loads just 50 records, and you should keep that in mind when looping through and keeping in mind which table are you working on. If it is always more than 50 records, you will be sending more queries to your SQL server and overloading it again. Okay. So let's move to the next example regards calcFields versus AutoCalcFields. So what's the difference here? Again, number of SQL queries and how much you overload the SQL server itself. So with calcFields and looping through, each time you execute calcFields, you will be sending one additional query to the SQL in order to calculate those fields, and it causes SQL overload. In second case, when you use AutoCalcFields, that statement is put in front of findSet, so you get optimized findSet query, which we will see in a bit, which will automatically include the fields which need to be calculated. Let's first check the demo. So for this example, we'll be looping through the vendor table with some filter, and then doing calcFields of, for example, balance, and summing it through. So simple example, that's it. But like I said, so each time when you execute calcFields, you will be sending additional query to the SQL, and you will be seeing that in a bit. So with setAutoCalcFields, you are performing that query before findSet, and when findSet is executed, it will be optimized query. So we will be doing setAutoCalcFields of balance, and then looping through and adding that balance. So the end result is basically the same. How that looks when we take a look on performance. So this is just run once, and the difference is significantly. because main reason is do those SQL queries. So number of SQL statements. You will see here that it is like huge difference. In this case, 25,000 like difference of SQL statements. And how does that happen? It is just the simple code, nothing else. So in order to understand better, let's take a look. Let's take a look on the queries. So there are a few queries here. First one, declaration, and then execution. So let's take a look, detailed look what those are. So first time with the findSet, you are crafting findSet query, pulling all the data you need, and then first time you occur on calcFields, you will be crafting the query for the sum, amount, from the vendor ledger entry, so on, so on. So we need the balance from the vendor table, and we will be creating this query. So each next loop, when it happens, so it executes that store procedure for each loop. So if you are looping 100 times, just through simple findSet, you will be executing the queries 100 times. So you see now why it's causing SQL overload like it is. So with findSet, you pull the data, and then for each record which you have again to point to SQL server to say, okay, get me the data from those fields which need to be calculated, and repeatedly. So that is what makes performance down. But when you are doing like AutoCalcFields, you're just having one query. So this is the query, full query. And you will see the second part of the query, which is different from the regular findSet. And if you take a closer look here, so it's again sum balance from vendor ledger entry, again the same similar query which has been done previously. So with AutoCalcFields, you prepare findSet automatically to do the results for that field with that query, with just one query. So with each loop, you are not creating additional requests, so you are using the same internal buffer which has been previously filled. And that's it. So let's move to the next example. So I'm sure you are being coding and then not paying attention too much whether you put in some procedure just regular record or just with var or just some fields. But actually it can make a difference. And the main difference between forwarding a record through the procedure as a var will be like transferring it with a reference and not by the value. And it can be beneficial in terms of the performance. But it can be also more beneficial if you ask yourself, do you need really that amount of the fields? Or it is just easier to transfer the full record and then work with it. Or you say, like, let's transfer the whole record, and then at some point I will need more fields to work with. So that can also have downside in the performance. So let's take a look first on the code. So first example with record as in a procedure. So we will be just looping through the customer table and just forwarding the simple procedure, the whole customer data set, and that's it. So without var, anything. And we just use the name field, for example. In second case, so we are using similar code, but now we are doing it with var. So we are transferring it with a reference. And in third case, we just forward what is needed. So if you use few fields in that procedure, you can just forward those and it will perform much better, which we will see. So here we will just call with the name and forward the variable inside the procedure itself. So let's check the results now. If you check the chart, first one is just the regular record, which is transferred by the value. Then the second column is transferred with the reference, and third one, we transfer just the field which we are needing. So the number of SQL statements and reads are completely the same. We are just talking about internal memory of the Business Central and how is that transferred from one place to another. And yeah, so in case you don't need full data set, just use fields. In case where you need to forward whole record, think about it, and maybe it should be with var record. The performance difference, like between full record and just field, is, so to say, significant. But between var and without, there is a difference, but you can live with it. So you should also think about it, whether it is worth to put var in front. So let's move forward. So here we was just talking about the memory. We don't have any SQL queries to show up. So what about now calculating the totals from the loop and with calcSum? The main difference between those two patterns are the place of calculation. So if you think when pulling the data with loop, you will be focusing with summarizing all the data on the platform itself, Business Central. And when you are doing with calcSum, you will be performing the calculation on the SQL level itself, which is much more optimized. So let's check example for that one. So in this case, so we are having one procedure, vendor finding looping through, and then summing budgeted amount, for example, and that's it. And the second example will be doing the same operation, but now with setLoadFields, because that's a feedback which I got, like what will it be better than the calcSum when we just load that field? So we will add that example as well. And the third one will be just the SQL part of calculation. So we will be doing set range, simple calcSum, and then assigning that into total amount. That's it. So first, let's take a look. So here we are having, calculating totals. So we have calculate totals in a loop, which of course takes a lot of time. But when you do setLoadFields, it's much better, but still not best as it can get. So with calcSums, you will be sending optimized query to the SQL and returning the value what you have previously done in much better time. So if you perform this multiple times and then take a look on the timings, it will be much bigger difference, and you can benefit from that one. So number of SQL statements in this case same, but the difference is in the query. So let's take a look on the query itself. So first query, just the loop, and you are just loading the full record, putting it in the memory, then slowly calculating all what you need. The second one you have with setLoadFields. So you're just loading the few fields which you need, and in this case you see it's much less query, so it's less weight query, much better performing. But when we compare that one to the sum query, which is executed on the SQL level, it cannot compete with that one. So that one is getting better performance on first place by the place of calculation and so on. Okay, so let's move to the next pattern. So if not insert, then modify. I'm sure you have been using that one, of course, but it has a lot of downsides. So first of all, it prevents buffered inserts. So that one you won't be accomplishing if you are doing buffered inserts. And the second one, which is mainly responsible for the performance, would be the SQL error, which is generated on SQL Server, then raised, sent to the Business Central, it parses it, and then second query is created and executed. So that's the main reason. We will see also graphically what happens. And it's mainly due to that reason of SQL error handling. And the pattern is not bad, but if you use it on non-singleton tables, it's, so to say, bad. But if you are using it for setup tables, so the tables which are singleton tables, it's highly recommended, of course. We are speaking just about the tables with some records in it, and you made mistake and the first query just isn't successful. So in this case, you try to insert, all good, but SQL returns an error, which triggers additional triggers, then parses on the Business Central level, and only that, then the modify statement is crafted to the SQL side and being executed successfully. So that first error makes a difference. So let's first take a look on the demo and then see how it performs. But the main question is there more efficient way to do it? So there is. So we will see in a demo. So let's first take a look on the code. First one, let's check customer. We assign some NL, which is already existing in the database, some name, and we try to insert. If not insert, then modify. And I'm sure you use that pattern on some places, but actually it can cause performance downsides. And what is the replacement for this pattern? So adding one additional query, checking just if it is empty in front, will determine whether you need insert and modify. And now you will say, like, there is one additional query. Yes, there is, but it is, well, much more optimized and better to execute that query than to raise SQL error and then parse it on the Business Central side. Even though we have here two queries, also for the get statement, but get, since it is always by the primary keys, it happens almost instantly, so we will not lose any more performance there. So better to do it like this, determine which statement you actually need, can it be inserted or not, and then execute correct one. So let's check the performance side. So if not, then insert, you will see like big gap. So just by checking if it is empty and then executing correct statement, you are performing it much better, since you are not raising any SQL errors. So number of SQL statements and reads. So we have a bit more. Do an isEmpty check, do a checking if it is empty, and then getting the record. So let's take a look on the queries. So from the query side, when you are doing, if not insert, then modify. So first you will be crafting insert query, executing, then error, like we said, is returned to Business Central, is parsed, then correct statement is crafted for the SQL and being executed. So, and that's what we said makes makes some time. With isEmpty and then correct statement, you're just checking if it is empty, and that is select top one null, which is really good performing query, and it doesn't cost much as you would make mistake with wrong insert. And then in the second part, you will be seeing that we are executing the modify statement since the insert, since the record is already existing in the database itself. Okay, so but let's move to the next example. If you are crafting some texts, and what are the difference? So between the text variable and basically the text builder variable. So mainly it is how the data is stored in on the platform, Business Central itself. So text builder is a wrapper inside of .NET. But text variable, you can still use it for storage of text when you already crafted some text and so on. But text builder, that's data type by the reference. So similar what we did with the var in front of the record and without. So here we have the text builder, which is stored in the memory by the reference, and the text data type by the value. So each time when you are assigning more text into the value variable, the memory needs to be relocated, and in order for new string to be added into the memory, which requires new allocation of the space, so each time. But if you use text builder, since it is by the reference and has a pointer to the memory, you just extend the memory by itself, and it doesn't cost too much when in order to add multiple texts into the same variable. So how does that look? Let's first check the example. So the example is pretty simple. So we are getting all the customers, then loop up, true. So the example is pretty simple. So we are getting all the customers, then looping through, and in first case we are using text variable, which is by the value. So each time new customer comes to be added the name into the text variable, you will be reallocating the memory inside the Business Central. So that's what is basically the downside mostly. And on the second example, we'll be doing the same thing, so looping through the customers and then adding the names into the text builder variable. So end result will be the same at the end, but the performance is a lot better. So we will be seeing that one. So here, as you can see, it's really big gap due to that allocation, and it is not that much of records and repetitions. So if you are repeating it a lot, on a lot of places, a lot of users, so you can multiply by that even more, and the difference is basically a lot. And number of SQL statements and reads are the same, and what we've spoken about is just that it is the optimization of the platform, how are those variables stored. Okay. Let's move to the next example. Modification in a loop versus creating a new variable, and maybe it's not fully clear from the title, but we will move to the code in a minute. So the first, when you are looping through, you are getting on the first batch 50 records. Then first read is uncommitted, and when you change it, it will change basically to read committed query. What is the code example in this case. So you are writing the code and then setting a range, for example, some random range on the name, doesn't matter. Then getting the full data set and repeating until and changing the address. So you've done that plenty of times. We are using the same variable. And in most cases, maybe you didn't know that maybe it will make a difference, but it will. So what if you would declare a new variable which you will modify inside your loop? So the same variable, just vendor2, same table, and saying, okay, that's vendor, assigning the same address to, and then doing modify. And you will say, okay, that would perform just same, and actually it won't. So let's take a look on examples here. And as you can see on the left side, we are just executing it once. And the left side was just with same variable. And but it's still looping through. We had the loop of the customers. So it's still looping through. And for each one, it takes more time than declaring the separate variable which will do the modification, do the reisolation which happens on the platform itself. So those are the examples maybe you do in your coding, but you don't think that maybe they can make a difference. And all the separate examples which we will show are worked separately, but if you combine them together, you will get the best, of course, result at the end. So let's move to the next example. Yep, but here, like, check the query. Query is not that interesting. So basically, the query for both examples are the same. Not too much interesting in this case. You are just, like we said, doing it on the platform level or the memory itself. Delete in a loop versus new variable, not to repeat myself, but it is the same principle with modify, which we had. And in this case, delete is not performing that much better when you declare a new variable, but it's still a bit. So we'll be checking the example. And here you will see like, setting the range, again, looping through, and then delete. And yeah, you will say for this example, it's pretty simple. You can use delete all, of course you can. But if you have certain conditions, and then based on certain conditions to delete, we are speaking just on this isolated example, whether you should use the same variable which you are looping through, or just declaring the new one. So in this second case, we are doing the same thing, but we are getting the vendor in the separate variable and then deleting it. So actually, since we are having and get query in front, it still performs a bit better. Not too much, but yeah, we are speaking about milliseconds here in these examples. So we can say double, but delete happens also pretty fast, so it's not that big a difference. Even if you are multiplying it on a lot places, you can do it, but the more benefit you will have when you are doing the modify query onto the same variable or not. Okay. So let's continue to the next example. So how do you check on some places, maybe, if the table is empty or if that table has just non-records? So are you using count 0 or isEmpty. And there is a big difference. So with isEmpty, you're checking select top one, which we'll be checking in a bit the query and examples. So for this, we have the queries for both cases, since the optimization is on the SQL level itself. And on the second, when you are doing the count, you are counting all the records from the table. So depending how big table you have, you will be performing better or worse, but you are counting the whole data set. So for small tables, yes, there can be a difference, but not that much. So we are speaking about larger tables in this case. So first, let's check the code. Simple one, that's it. Just vendor, which had 1,500 records, maybe, and checking if it is 0, then exiting, and in the second example, if it is empty, then exiting it. So basically, both queries are simple ones, but the difference which we will see in the queries is basically what is loaded in the SQL, what is being checked. So first, let's check the results itself. And here you will see better performing isEmpty check instead of the count. And for the statements, same number of statements, but you will get with the count more readings. And that's what was previously said, that with the count you will need to take the whole data set and check it, versus isEmpty just checks if select top null, one null, and that's it. So almost no reads versus reading however you have in the table records. So in this case, we run it 500 times on the 500 records table, and it had 500 reads. And if you do it on even bigger and bigger tables, the difference basically in duration, so the benefit which you will have will be greater and greater. So the bigger the table, the better the difference between these two methods is. So what happens on the SQL level? So when we execute the count, we are doing the count on the table and then reading the full table itself. So in this case, 20 records, but with select top one, here we are just reading the one. So we are just selecting the one, checking if it is empty, and that's it. So that's main difference there. What about temporary tables? So do you use the benefit of those temporary tables? So we will not have SQL examples for this one, since when you are using the temporary tables, you don't craft any SQL statements and send to the SQL itself, since everything happens on the platform itself. So no SQL queries, and the read, insert, modify almost happens instantly. So you should basically use and benefit that from. So we have a bit more examples here. So just the regular table created, then inserting it, looping it, and then deleting all the records. So all the operations which you can do. So we are doing it now, except modify. Yeah. So we are inserting, looping, deleting. In the second example, we are using the same table, just declaring it as temporary, and doing the same operation. Of course, that one will perform better, but can we do it further? So what if we can declare the same table as a temporary table? So the regular table here is just normal one, versus the temp table which has table type temporary. And we are doing basically the same type of the operation here, but not declaring any temporary since that table is already temporary itself. And you would say like both are temporary tables, no SQL statements are executed that must perform the same. Actually, not really. So let's check it. Of course, so with normal table, we will be getting enormous result. So that's pretty obvious. So let's just check the statements. So we will see that normal table each time it says it sends the query to the SQL itself, then parses it, and so on and so on. So let's just remove the logs from that first statement, and then take a look here, just to have, because the first one was too big, and we couldn't see the results from those two. So if you use normal table, just declaring it as temporary, you will get the benefit of the temporary tables, of course. But you can get one step further with using your table as temporary table. Based on your needs, your processes, you will be determining whether you should and whether it fits your logic. But the difference is present. So if you are declaring the table as it is temporary, you will be gaining additional benefit from the optimization itself, which happens, and that one will perform even better. So we've spoken about temporary tables. So the queries, first one is crafting full query. Each query for each operation which we do, insert, delete, looping with findSet, everything is executed. And this is one with temporary. So I selected all the queries which happened in that session, and we cannot find any statement executed from the SQL server, whether it is insert, modify, or findSet, which we was executing, so nothing happens on the SQL level itself. And if you're using the temporary tables, maybe in some cases, if you don't need the full data, you can use also the dictionaries. So basically, the both types are virtual. So nothing is on the SQL side. But again, due to the memory optimization and how the platform handles, one way or another can be better performing in some cases. So different scenarios you need to choose by your needs. So let's check that one. Let's first see the examples here. So we will be using first the temporary table, but with some partial records, just with some records from the table. In this case, ANO and name from the vendor table, and that's it. So we are not needing the full vendor virtual table. And in the second example here, we'll be doing exactly storing the same data. So ANO and the name, again, of the vendor, and storing it now into the dictionary. So different place of storage. Both, as we said, are virtual and don't send any SQL queries itself. Then we have two more examples. What if you need like the full and complete record? So in first case, here we are transferring the full vendor table, then doing the insert. And on the second place, we are doing the complete record, but with dictionary. So we go by the vendors, repeat, and fill the dictionary table by the values. So, and this is the part where the downside happens. So let's check those examples here. So first two, which we have are the temporary table with partial record and direct dictionary with partial record. So we are not getting the full fields, all fields. And in this case, if you use dictionary, it will be better performing than temporary table. So based on your field numbers, how much you need, you should decide whether to use dictionary or temp table. And in second example, it's another way around, and another way around in terms of the performance. So you will be getting the temporary table with complete record versus dictionary with complete record, and it's performing much better in that case when you use the temporary table with complete record versus just filling the dictionary, because that will cause too much overload and in the storage itself. Okay, and obviously here we don't have any sequels, so since both are virtual. Let's move to the next example. Find first, then loop through. So if you didn't notice, but that's also code cop rule, this one. So basically what we have mentioned in some of the examples is that you are getting internal buffer size for just one record, or the cursor, which was in a vision. So basically this was from the old days also the downside. And if you need more records, then we are sending additional query to refill it, and then you need to reallocate more memory also to it. So in that case, record set which is following can be too big to fit in the already allocated buffer size. So memory reallocation needs to happen in order for the second query result to be stored. So find first. Next, no record in the buffer. We are reading it again from the database and selecting the next data set. So let's check that graphically. So you're doing find first. SQL is returning just one, and you can still do the next statement. But when you actually do the next statement, the new, again, similar to what we had with find minus and find plus. So you will get just the 50 records. In this case, you will get only one record, and you can still get additional ones, but it will take one additional query to fill data set, and you will still be able to continue working with it. It just needs more time and more calls to the SQL itself. So let's check the code first. So here, again, simple examples for better understanding. Just vendor, find first. We are getting one record. We can still do repeat until, no problem there. But when first time next is executed, you will be doing the call to the SQL to return the full data set. That is also possible. You will still have a working code, but again, memory relocation and one additional query, it costs you. Find minus, I just put it so we have it in the comparison of the performance. So here, previously we mentioned, we will load 50 records with the next. If there is more than 50, again, you will need memory relocation and again, to fill again the buffer with different data set. Versus just doing the findSet correctly, according to your needs, correct filters, sortings if needed, and then repeating and looping through. So you are just getting one query from the beginning, and that's it. So let's open the demo kit here, and you see how we go. It's basically the order. So with findFirst, one record, a lot of memory relocation needs to happen in order to store it, and also one additional query. So let's switch to the SQL statements. So in the first two examples, you will be executing first one, like findFirst or find minus. And on top, when you reach the end of the buffer, you need one additional query to be executed. And that's basically the difference regards this performance here. So better to determine in front which type you need it. Okay. So let's continue presentation. So here, what happens on the SQL side? You will have first select top one. You will get the full record loaded, and immediately when you execute next, it will say, okay, I don't have next record, but similar to minus find minus or find plus, it will start from that previous record. So it will not be that one. Won't be loaded into the next data set, but the data set is refilled with fresh data which needs to be used. Let's move to the next example. So the next example would be, are you using, and whether you are using isEmpty or findSet. findSet, of course, I hope you are not using, before modifyAll. So isEmpty is already checked on the SQL level when the query is being crafted. So in the same query, we'll be seeing that the number of rows which are in the database table are already checked. So with findSet, you just perform additional selection, storage into memory, and so on. So that's not worth at all. And the logs which happen here are intent exclusive log, which happens on the page, same, and on the row level, just exclusive log. And modifyAll, in this case, just performs all those checks for you. So let's check the examples here. So first one we will be doing, if not isEmpty, then modifyAll by some filters. So first one, just setting name filter, checking if it is empty, modifying all. The second example we will be doing with findSet. So loading additional records in the data set. And the last one, just simple filter and simple modifyAll. That's it. And how is that looking on the performance chart? So isEmpty, one additional query, which is already checked with modifyAll, and takes additional time, of course. Only modifyAll is just performing much better. And if you're doing findSet, of course, logically, you're storing all the data set. You're having also memory allocation and storage. So it performs much worse. So definitely never use findSet here. In terms of statements, so we will be seeing like that the last one, just modifyAll, doesn't have that one additional query which we had with isEmpty or findSet. And that's what here makes a difference. So the first one, it makes a difference the query number and query execution, and the second one, the data set which needs to be stored and allocated into the memory itself. Okay, let's move forward. So filtering on the FlowFields, is it the same or is it the worse as you are looping through and then using the custom filter on it? So basically, the filter on FlowFields is not bad as expected. So you are expecting that it does the calculation, and it actually triggers calculation for each record, but it is not really bad as you are looping through, and it is in some cases good as AutoCalcFields, and in some cases just even faster. So what we are speaking about. Filtering here. So customer setting filter by the balance, finding the set, find set, and then repeating. So we are, yes, sorry, thank you. So we are setting the filter on the calc field and calculated field, which needs to be calculated for each record, and then doing the find set and repeating until. Versus when you are doing AutoCalcFields in front, and then use it in the condition itself. So basically the result is the same, and AutoCalcFields is performing also pretty good, but both results are not the first result is not bad as expected. So in some cases, like in my example, so when I ran, 9 of the 10 times it was like this. So the difference is really small, but with filter just on calc field, it performed even a bit better in some cases like this. So if not the same, you will get even better result on filtering it. So don't be feared to use it to filter on calcFields, because it will perform just as good as AutoCalcField. Let's move forward. Lazy evaluation, and I hope you're using the benefits of it. So basically, when you are checking the certain conditions in your code, it matters. Best would be to exit early as possible, and this is what I have been also seeing when contributing to Business Central open sources. That a lot of developers are just nesting the loops and executing all the conditions, even though it can be early exit, and you can optimize it to quickly exit whenever it is possible, so you don't overload anymore. So we have some examples here when you need combination of the conditions, and when you need just some condition to be executed. So in the first procedure here, we will be using no lazy evaluation. So we will be executing first condition, then second condition, and then executing some code if that is true. So the first one always returns true, the second one returns true, but also has some heavy-duty code inside of it, so to say. And how you can do it better? Like I said, so you can check always your code, whether you can exit it early as possible. So in this case, it also matters the position. How do you structure your code? If you put first the heavy procedure, doesn't make any sense, because you will get again the slow results. But if you determine which conditions will take less time, you can early exit and benefit from it, not executing all the conditions. So how you can also do it is with the case statement. And here again, the order, how do you put the procedures also matters. Whether you put it first heavy, so it will be by the order. So if we do the case statement just other way around, first heavy duty one, so it will be performing worse, which we will see. So you can also do it with in statement, and here again it always depends how you structure your code and which procedure or condition is checked first. So in true, so it will be checking first one, then second one. Immediately, if it is found in either of the condition, it will go to the code or exit. So in this second example, I just rotated those two, and we will be, since this one is returning also true, we will be executing just the first one, and that's it. And we have two examples with and condition. So when you need both condition, better to do it like this. And in this case, you will just run the second procedure only when it is necessary to do it. So in first case, you will do first one. If that is false, you will in first case use execute first one and the second one, and in the second example, the first one, and if that is returning false, the slower one inside it won't be executed. So let's take a look on the examples itself. So we have pretty much of those. So without lazy evaluation, you will get more time than just do executing the slower procedure. When you have any of lazy evaluations with either or case with casings or in or early exit, like we have in the first example, so you will be exiting it immediately and avoiding executing slow procedure, and that's basically the point of lazy evaluation. Similar to those two end result, with when you have two procedures which both needs to be true in order to execute some code. Okay, so let's move forward. Changing the filters inside the loop. So what will do that? So when you do that in your code, it will invalidate your record buffer, which you have already filled in. And when you trigger the next statement, the new query needs to be triggered and executed to refresh the buffer which you have. So even though the first records are loaded correctly, you will need additional query to repeat. So it sends just unnecessary load for it. So let's check the code here. So changing the filters inside the loop. So we are setting some filter, set range based on the country, for example, then findSet, looping true, and we have condition. So if, for example, international shipping for that vendor, we set range to different filter. And what it does, it invalidates like full data set and fills another data set instead of that one. But you can do that just with some temporary tables like we covered earlier, and avoid that one. So you should not do that to the reason that you will invalidate the data set. So you can still loop through all the vendors, then check the condition, and just either save it into the temporary or just mark it, and then use it below to do the separate operation for those. So even though we are then using findSet, but on temporary, which performs much better. So that part, this part of the code performs much better than previous one when you are invalidating the buffer. So changing filters here. So when you change the filters inside the loop and we execute it just once, there is a big gap in performance. Even though we have like 15 lines more, but those are everything for temporary tables, and no SQLs are being exchanged between Business Central and the SQL server. So the first one is performing just better, and number of SQL statements is of course less than just invalidating the buffer. Okay. So here, what we show. So first, the query was crafted with correct filters and everything. So data set is filled, and when you invalidate data set, you set different kind of filters and execute that against stored procedures procedure which has been already crafted for that filter, but the memory is erased and filled with the new one. So next one is isEmpty or findSet before deleteAll. It is similar to modifyAll, but it can also have some downsides. So let's first just check as we did for modifyAll. So isEmpty just additionally, findSet fills unnecessary record. We will not repeat this part. And for the examples, so isEmpty before all, so we are checking if it is empty, then, yes, sorry. We are checking if it is empty, then deleting all, then doing some insert. Then you are seeing that we are doing insert after deleteAll. And in the second place, we are doing findSet, if findSet, then deleteAll, then some insert. And on third example, we are just doing deleteAll and then insert. So for first time, we'll be doing that on the table which is never empty. We always fill it between the runs. And in those cases, isEmpty before deleteAll performs worse than just deleteAll. And if you findSet, of course, it is just for comparison, but I hope nobody use it like that. So findSet just loads additional data unnecessary for this operation. So isEmpty or deleteAll. So in this case, when you have the table which is never empty, you gain the benefit and the benefit of having one less query, and it will perform actually the better. But, so let's return here. So what is happening in the query? So even if you are doing deleteAll and that table is empty, that one is checking if row count is actually different from the 0. So if there is any records in the table, and if so, deleteAll will be executed. Otherwise, it won't. But so just a second. So isEmpty and deleteAll. isEmpty query, just checking if it is empty, then doing deleteAll. Doesn't matter at this point to you, but does lock behavior happen here? And answer is still yes. So it does happen. So I did also some additional tests. So when you actually hit the table and when that table is empty, and you are performing the inserts afterwards, so it will perform worse. So we will be executing the same code. Here it is. So the same examples, not to go through once again, but we are doing, if not isEmpty, then deleteAll. So that's important, that one isEmpty before deleteAll. So let's run. Sorry. Not. deleteAll. Let's check that one. And we see the duration now, just deleteAll, that it performs less better than together with isEmpty deleteAll. Because if you hit the empty table, it will lock it itself, and then with the insert hit, it will take more time. So that's one thing which you need to keep in mind. And one more example for the end. So count one. So how do you find one if there is just one record in the table? So if you are doing count one, you are performing, like we said with count 0, you are checking the whole data set. And if you're checking like on a lot of records, you are checking a lot of data set. So with find minus, it's better. You are selecting 50 records, and find first one additional query just to pull additional record. So let's check that code first. So first, we have count equals 1. So here on 1 million records, is the customer having just one record? Not. OK. The second example is findFirst, then next. It can be a way. It will give correct result. But with the next statement, like we said, for the findFirst, you will just have one record in the data set. So one additional query to fill data set again. And third one is with find minus, where you will pull 50 records in your data set and then say, OK, let's go next. And if that next is succeeded, then you're concluding that you have just one record. And that's it. And when we check on this large table, the results are significant. And this is just one repeat. So if you are repeating it multiple times, it can be significantly worse. So I have been also running it with 500 times, and we are ending it with 10 to 20 seconds difference between count and then checking find minus with next. Even though there is one additional query, but the result in durations. So, but the result in duration is much better when you use find minus and next. Okay, so first, let's check that one. Here, count full data set, we said. With find minus, we are up. With find minus, we are loading the find first. We are loading the first data set, then completing it with additional ones. And with find minus, we are loading just the 51, and we can check in the buffer which one to fill. So find minus, pull 50, then first record with next check. Just check if the next one is existing. Yes, okay, that means that's it. So I would also invite you. So since you are in this large number, so we are trying to gather more traction into official AL guidelines. So these AL guidelines have been originally created by Henrik, Waldo, AJ, and Jeremy. But we are planning to bring some more traction and involve much more customers and partners, developers from your side to get involved with it. And that's actually, if we take a look here, pretty good. You can check docs, see valuable patterns, and that will increase by the time we speak. It will be more and more. And also one thing I think maybe you didn't know, but it is under the Microsoft repository. So Microsoft is the owner, and it would be very beneficial if we have one place where we will define all the patterns, and then also for open source contributions, you will follow those patterns, and then we have much less time to spend on reviewing some additional features. So you are able to ship your features into open source much faster. You are not getting that much comments into reviews from other community members or Microsoft. Okay, since we are having some t-shirts here, let's see if we have any questions here. Okay, we have 4 t-shirts. But questions, we can do more.
So I have two questions. One is that...
but one t-shirt.
Yeah, one t-shirt, but 2 questions. So about that, if insert on modified pattern and temporary records. So in temporary records, does it make any, difference, the same as was with real table?
Yeah, basically the real table, whatever you perform on the real table, you will create the SQL statement and then communicate the SQL server itself. When you do with the temporary table, there is no SQL queries, no communication between SQL server and the Business Central itself.
but then that if insert then modify, if insert then modify on temporary table, so is it?
No, that's fine. Because again, the main downside for if not insert then modify, would be the SQL returning the error and then parsing it onto the platform, then returning the signal again to the SQL server with another query.
And another question about the setAutoCalcFields and the blob fields. So let's say if you in the repeat sentence you only usually use calc field on the blob, but only in certain condition. So is it better still do setAutoCalcField on blob?
If the condition is really small, and of course the number, I think still not, because depends on the condition. Like if it is like just few occurrences, without setCalcFields you will always calculate, but good one. So you can avoid like loading it for certain conditions, which you cannot do with AutoCalcFields. And in those points, I fully agree that those make sense to use just the calcFields.
Yeah, thank you.
Thank you. Yes. We can do our next there. Try it.
So when you compared the performance between using the record reference against using a field as parameter, did you do the test with multiple fields too?
Yes. Up to, like, so to say, I did the test to 3 to 5 fields being transferred, and the result is same. So anything above that, I would not consider because it is just the code is not maintainable. So you get the performance side better, but the code just looks wrong. So if you put 10 parameters inside the procedure, then it doesn't make any sense in the code-wise and in the performance-wise. But if you keep it low, like few fields, that's totally fine. Not only one, but let's say 3 to 5, maximum 5.
Okay, thank you.
Throw it. I will come back to Arthur. Up.
Thank you. I have a question about query objects. Can you share any insights on performance and how SQL queries are created when comparing a findSet to a query object?
Yeah, the queries, when you use the query object, the queries which are crafted are much different. So of course there is benefit of it. So even with calcFields, if you use the queries itself, it will gain more performance than just to use the regular one. So it's different logic. We didn't cover that one here.
How about the difference on just flat query objects when you just read one record without any FlowFields on it?
How do you mean?
Is there a difference between a findSet and a query object? Do you have any insight on that? I mean, if you just if you don't
yes,
use
there
any
is.
FlowFields.
Yes, for the first run, not for the repeating times. When you run the query, it will be much better performing than findSet, just findSet.
Okay, thank you.
We have a lot of questions, but we can cover all the questions, but. Yes, yes.
I have a question on the modification in a loop, where you're assigning to a new variable. From a code perspective, it feels a little bit counterproductive. Have you any insights on why it performs better?
Yes, actually yes. So inside the memory, since especially for the modification, since modification you are doing it on read committed, so it needs to be changed to read uncommitted in order to do the modification, and afterwards to continue. So in those terms, that's the difference when you are doing basically the read and modify on same.
That is correct, yes.
course, not to perfect.
My question is regarding using the setCurrent key, because I see a lot of developers that is using setCurrent key all the time when they are using a findSet. And how do you look at that perspective?
So if there is one key, and that one key is primary key, that's not necessary.
I see it if it's...
If you have different kinds of different
kind of values that you're gonna set range on.
It's worth setting it, especially if you are doing it like find plus, for example, and starting with some order, whether you want to load the records from the beginning or from the end. It's better to use correct keys and then set ascending or descending, for example, and that will perform even better. But if you are using the set current keys, it can be better performing. That depends on the case, basically. Not always is necessary, but in some cases, yes.
From what I have seen is when people are using it with the findSet, always that
not necessarily always.
Sometimes that it will always in the SQL query behind use an order by statement, and there you will have some overload in the SQL, because it will always start to order the data before it's just getting the data that you just want, and let the SQL handle with the best key available.
I would start without set current key, and then use the SQL insights from the debugger itself, because I had like few examples when I was working with VAT statement lines when it is pulled, but not directly. So from other part of the code. So it was like loading one report like 20 minutes, and it just needed one set current key on that VAT statement lines, and it performed like in less than 2 minutes. So it can be really beneficial, but depending on really scenario and digging through, like on the eye you cannot see it, but looping through the debugger, then checking the queries which are executed, you can see whether it needs to be setted or not, and then setting it correctly, it can benefit a lot, of course. You can. Do we have to break? Yes. You can find me afterwards there. Thank you.